Hello, and welcome everyone. I'm Juho Heiska. I will be your moderator today, and I'm very happy that I was actually asked to be your moderator here today. I'm quite young still. I did my PhD in Aalto University around batteries, and I'm very enthusiastic about this developing field that we also have here in Vaasa. Today's first session is the Energy Storage Seminar 1, European Electrified Future. I don't know if you have heard of this saying that the first rule of reducing emissions is to electrify everything. The second rule is if you fail to electrify everything, try harder. And the third rule is then find some alternative solution to storing your energy and then using your energy. But without further ado, I would like to introduce our first speaker, Michael Lepert, who is the chairman of the board in Batteries Europe. Thank you.
Thank you very much. So, good morning, ladies and gentlemen. And I'm very pleased to be here in Vaasa. It's really an exciting experience to see, whereas I'm very much in batteries and have been in batteries for 30 years, to see in particular this dynamic here in Finland. I've been to Kokkola yesterday to learn more about the upstream side of materials, which I'm not usually dealing with in every day. So today I'm here with in my role of chairman of Batteries Europe and BEPA, the Battery European Partnership Association. But in my talk I will give you a little bit more details about this. Maybe to start with, and I'm really directly linking to what you said about electrification, let's start with a cartoon. These people say, we don't want fuel from Russia or any other nasty regime. I mean, it's quite actual things. So what do you think this guy will tell them how he can help? Actually, well, he will not have an alternative fuel solution, but he will suggest them to change their energy carrier, to go to electricity. And that's what we are talking about today, because I believe that in this coming decade, everything we can electrify will be electrified. And why is that? Well, 40% of our greenhouse gas emissions worldwide are coming from the power and the transportation sector. So if we want to do something about greenhouse gases, these are the two sectors we need to work on. And electrification is obviously the way. On the one hand, massively electrify the transportation sector, and which not only means electric vehicles, but it means vehicles, trucks and buses. It means trains and boats and airplanes. And on the power side, of course, we need to shift to locally produced clean, renewable energies, which will not only help to overcome fossil fuels, but also to create more energy independence from, in particular, Russia these days. So, first message here, and all these areas do need batteries, obviously, in order to electrify transportation. We will need batteries in order to integrate variable renewable energies into our grids. We will need energy storage and batteries in particular. So, whereas batteries have been around for more than a century, mainly as a backup function or to power your mobile devices, your phones, we are changing paradigm. Battery technology will become, I think it has become, a key technology in order to electrify and to reduce our greenhouse gases in the power and transportation sector. This is very much recognized at European level. If you look at the recent Fit for 55 package, so reducing by 55% greenhouse gas emissions, there are 14 proposals, 9 of them directly or indirectly favor storage. I don't go into details, but it is acknowledged at this level. So clean energy does need battery technology. And we will need them a lot. You see here the increase of the need of batteries between 2020 and 2030. Don't look at the figures as such. It's a 14 or 20-fold increase of battery production in order to power, in particular, the transportation sector, but also about 10% goes into stationary energy storage. The question is, this is a whole lot of economic wealth And the question is, can we make this in Europe? Can we keep this economic wealth here in Europe? And this is, of course, a very strong political and economic will in order not to let this go to Korea or China and to live again what we have seen on the photovoltaic side. So the answer on this question, obviously, today is yes, because you have all heard about the gigafactories, and this is from February, and I saw 1,200 gigawatt hours of gigafactory projects in Europe. So this is very huge and ever increasing, and a huge amount of battery manufacturing capacity that we will see in Europe. That's nice. But there is a but on this, and this is coming in black. You do not need only to produce batteries, you need the raw materials in order to do this. And there we see on this chart that China is dominating, is leading not only on the mining side, so on the production of nickel, cobalt, which are very important for batteries, also lithium, of course, but also on the refinery side, they are really dominating this area. And this is our challenge, and this is where, in particular, of course, Finland has a role to play on this raw material side. Not only we need to avoid to come into another dependency, and we need these raw materials, we also need to be sustainable in what we are doing. And here again, the raw materials are key. Because if we say sustainable batteries, it does not only mean the carbon footprint of these batteries. We're talking about economic, social, environmental sustainability. So things like sustainable sourcing. Where do we get the raw materials from? And do we employ child labor? Do we put the people under healthy conditions to get these raw materials? We're talking about carbon footprint. We're talking about hazardous materials which we want to avoid. We're talking about recycling and second life. Everything is related to the materials, and for very good reasons, because you probably know that in a battery, about 50% of both the value, or even more, of the raw material and also of the carbon footprint is coming from the raw materials you put in. The upstream raw materials are very important in what we are doing for the sustainability and the cost of the batteries. Now, what is the link to research and innovation? I put this up front in order to introduce the fact that, well, if we want to have a leading position in Europe to produce competitive, sustainable, mass-produced batteries, obviously it has to do also with research and innovation, because we need to invest in research and innovation in all these areas. You've probably heard about the European Battery Alliance. That's when it started, from Commissioner Šefčovič in 2018 about. He initiated this initiative at European level with one credo, which is to say we want to have this industry in Europe in a competitive and sustainable way. And they developed a strategic action plan for batteries, including a number of regulatory, financial, and other measures. But one of the cornerstones of this plan is and was, of course, research and innovation. And for this, let's say 3 bodies were created historically. The first one is Battery 2030 Plus. So this is where the research community comes together, and they especially think about very long-term research. Batteries Europe is the think tank. It's a European technology and innovation platform where we gather 500 people thinking about what R&I do we need for the future. And BEPA is an association that is sitting in a partnership with the European Commission and nailing down into paper the research and innovation topics, the work program, which will get European funding. Because Europe has ring-fenced a 925 million budget for battery research and innovation, and we are sitting in this partnership together to define what we do, how we prioritize, and how we finance this. Of course, behind this there is a strong link with different national and regional stakeholders, with the important projects of common European interest that are ongoing, and with other research international communities. So what means research and innovation on batteries? I see mainly three dimensions. One is the maturity level, or TRL level. We need to look from very short-term needs to very long-term needs. We need to look at it along the entire value chain. That's what I said. Raw materials and advanced materials are as important as the cell technology and cell manufacturing. Likewise, up to recycling technologies, where we still have to do a lot of things. And we need to look into different applications. It is not only electric vehicle. It goes from home batteries to grid-scale batteries down to the different transportation areas. So, in Batteries Europe, accordingly, we are organized in different working groups and working streams. I don't go into all the details, but you see there are people working more on raw materials, advanced materials, cell design, and so on. And we have cross-cutting working groups working on sustainability, safety, digitalization questions. As I mentioned, there are 500 experts from all over Europe, from industry and research, who are working on these programs. Very quickly on BEPA, as I said, this is a partnership. So BEPA, the association, represents the private side of this partnership. The European Commission is the public side, and as I said, we define the work programs 2021-22, 23-24 that are financed under Horizon Europe, which is the European budget. Knowing that, in this partnership board, we are mainly looking on the core activities of batteries. So, in particular, the advanced materials and the cells, where things like upstream and in particular the integration into vehicles are dealt with other partnerships and other bodies. I have to speed up. So the process is we have a think tank in Batteries Europe where we have a holistic view on all the topics, and this is then channeled down into a work program, for example 21-22, defined and published by the European Commission. Again, just to give you a flavor, this is the first 2021-22 work program for a total budget of 300 million euro, spread in 2 years. And as you can recognize, there are calls, and each call represents a couple of million of euros of funding available in the areas of raw materials, in the area of advanced materials, in the area of battery end users and operations, and some coordination action. So it is well structured, and what we have, I think, achieved is to define the different working areas along the value chain. So the first program was out in 21 for, I think, about 20 projects that could be financed. We had 60 projects submitted, so it is pretty much oversubscribed. I think I skip this. Is just to say that depending on the area, we work more or less deeply with the automotive industry, for example, and but we also work with the shipping industry and the rail industry. They have of all interests into batteries, and their level of integration is different. Now, some thoughts about the research areas. What are we talking about? I can spend half an hour on this slide, but to give you in particular an idea about what we do in raw materials. So it's a question about how can we improve sustainable sourcing? How can in the mining industry and in the processing industry can we reduce the energy intensity of these processes? In advanced materials, of course, we look into different battery materials, in particular towards the solid state, but also characteristics like fast charging. Now I was too fast. an important area that was left aside for a couple of years in Europe was manufacturing. Manufacturing technologies, Industry 4.0, digital twins are all areas that are necessary and that will enhance our capability in Europe to produce cost competitively the batteries. And just to go to the final point about recycling, we need to ramp up our recycling capabilities, but it has also to do with technology. How do we sort, collect, and dismantle batteries? Very important. What are the different recycling technologies in order to get high-grade battery materials out of this process in a cost-effective manner? We are not really yet there today, but we know we need to get there because we absolutely need recycling processes in order to recover our raw materials. And my last point is just one idea that will come in the 2023-24 program is the battery passport. What we want to achieve is a digital twin of each battery for which all along the value chain, from the materials through the production and to the end use and recycling, all the stakeholders along the value chain feed data into the cloud, into a digital twin of the battery, so as to, first of all, have a measurable criteria for sustainability. You will be able to say this battery has this carbon footprint, is this much sustainable compared to another one. And at the end of life, of course, we have all the data needed in order to effectively manage the end of life. Say it can be used for a second life, or it has to go into this or that recycling process. So that's what I wanted to share with you today. I guess you get the proceedings. I put a number of links if you want to have further reading. And of course, there are a number of documents, in particular, published under or by the Battery Europe a platform. So if you want to read the roadmaps per area on about active materials, on sustainability and so on, they are all published. And of course, the Horizon Europe work programs are published, so everything is available on site. So I'm probably a little bit over time, but that's what I wanted to share with you today to introduce this Battery Day. Thank you very much for your attention.
Thank you so much. It's amazing the work that you're doing in Europe in the field of batteries, because at the beginning of the new industry, you always need regulation. You need the regulation power to get it going after then when it comes a bit bigger, then it can become a self-sustaining loop. Next, we have Staffan Södergaard from ABB, coming to talk about rapid expansion of European battery value chain. Let's give a round of applause.
Perfect, thank you, Juho. Good morning, good day, everyone. Nice to see such a big audience of bright and cheery people coming to listen into this session. I like to start off with a question, typically. So, how many drives electrical cars, fully electrical cars here in the audience? Good. And how many of you, I'm going to pause that and come back to a second question later on, actually. I'll hold that one I have a follow-up question later on in the presentation. Anyhow, my name is Staffan Södergaard, and I'm responsible for the offering within ABB to the battery manufacturing industry. And today in this session, I'm here to share our thoughts on some different contexts in both the market, in the challenges we face, and how we can go about in solving those challenges in this industry as we scale it. Good. So let's start out where we are. I think it's not an overstatement to say that we are living the energy revolution as we speak. Looking at the fight on climate change, we can see all over the world that we have policy coming out of governments and public officials in order to support the decarbonization of the transport sector. And the way to decarbonize the transport sector is to go and electrify it. And in order to do that, you need batteries, and you are going to need a lot of these batteries. If we look at other industries, we have the energy storage. We will definitely see a tremendous growth also in the energy storage aspect. And who knows, aerospace, there's already a quite big interest from the aerospace industry looking into how they can apply this technology also into their industry. And if we look at the players in the market, and especially the automotive industry, all major car manufacturers, they are actually the ones driving the growth in the market now. I would claim that they have a clearly communicated electrical vehicle strategy towards their investors, towards their stakeholders, and they need to commit to that strategy and the promises that they have made also. So the demand is in that sense robust, and now I'm going to come back to the questions I had to support my statement that this is a revolution because nobody wants to go back. How many of you who drive fully electric cars would go back to an internal combustion engine car? Interesting, I see no hands, so that would say it's not an overstatement to say that we are living an energy revolution in that sense. So, interesting. We have a 9 to 12-fold growth, 10x growth probably ahead of us in Europe, and this offers great opportunities, meaningful work, a chance to build great industry projects and fight climate change. What could be better than that? Well, there are some challenges as well that we are facing. It's some clouds in the skies as well. In order to be able to efficiently ramp up production in Europe, we are going to need a lot of resources. I'm not claiming that these are the only challenges, but these are some of the key aspects from our perspective. And in order to secure those resources, it could be both financial resources, it's competence, it's capacity, it's a lot of things going into that bucket. Also, if we are going to do this by 2025, 2030, whatever time horizon you are looking at, there will be challenges in being able to support the industry with the equipment going into these factories. We are not only talking about building a physical factory. You have quite advanced equipment that you need to have a supply chain that is managing to create these machines that you need to have in everything from coating, calendaring, slitting, formation and aging, and whatever part of the process you look like. These value chains are not ramped up or geared up to be able to supply that. So today I would guess that you have a lead time of 1-2 years, even more, and this needs to also be matched with the growth that we see ahead of us. Then of course we have the raw material aspect as well. As the previous speaker also pointed out, everybody, all the regions are talking about and having conversation on how can we localize the supply chain. It's a lot of economic and financial aspects of it, of course, because it will generate wealth. But also we need to take into account that as we look at the world today, nobody wants to be too dependent on other regions. So there is a strong momentum both in Europe and North America, also Asia and China, to have their own localized supply chain. And looking at Europe, where do we have this raw material? There's not that many projects that is up and running. We don't have the sites open, and we don't have the processing capacity developed yet. There are, although, quite a lot of ongoing activities and initiatives and prospects in Europe. And now we are talking, of course, about the raw material for lithium-ion batteries like manganese, lithium, cobalt, nickel, these type of assets. And then, of course, we need to do this also in a sustainable way. Not only how we mine them in a responsible way, the raw materials, but also if you look at the carbon footprint today of a manufacturer, you could have a quite big difference if you choose raw material from one supplier or another. It could be a delta of more than 40% of the CO2 footprint. So that's huge. And the way to go around this is, of course, that you need to also electrify the supply chain and do that with fossil-free energy. Otherwise, you are not really helping the situation from a fight on climate change perspective. And of course, also we cannot just produce more and new batteries without having a good plan on how to take care of them as they reach their end of life. And there are, of course, a lot of interesting things ongoing within the recycling aspect of it, but also in terms of the second life and applications for used batteries. But the key here is really to unlock the value of that residual battery. How can you have a value on that item when it's used? It's a lot of discussions ongoing and conversations in the market, even banks looking into if they could own the raw material and lease it to the market. So there's a lot of innovation probably going to come into these aspects also. But key here is, of course, that we need to do this in a very sustainable way. And then moving on, the question is, will Europe keep up and how will we manage with this? There's a tremendous growth all over the world in different regions, and the key here is not only to keep growing and do what we have planned, we need to outgrow the other markets. I think today more than 85% of both cell manufacturing capacity and raw material capacity is coming out of either China or Asia. And they are also building, expanding and growing very fast. So we need to actually outgrow that pace if we want to take up the competition with them. And there are several aspects that, from our perspective, since ABB is working all over the value chain, for historical reasons also, all the way from the mining, how we electrify mines, to how we are building the actual processing plants where we are making the active material, how we robotize and automate and digitalize the cell manufacturing plants, and how we are working with recycling aspects also. So from our perspective, we believe there's a lot that can be done, and both from our industry ecosystem, I believe that will be a part of the solution on how we can leverage competence from different industries today. I mean, look on how we are printing paper at the speed and the rate and the size of those machines. Look how the quality control is done within the semiconductor in this industry, and look at the pace on when you manufactured microprocessors before 10 years ago and how you do it today. I think there's a lot of learnings that we can basically frog leap from and implement into this industry. But that's not the only thing. It also needs a lot of private and public funding and support and policies that also supports this, and decision making needs to be correct and responsible and fast. Furthermore, also looking at the equipment suppliers, I think there's room also for a lot of new players in the market. There's not that many in Europe that are manufacturing equipment going into these plants. There are a few, and looking at manufacturers of equipment in other adjacent industries could also probably frog leap into this industry. So hopefully we'll see a lot happening here. And basically the industry is quite young, and we are just scaling the solutions that we have today, but there's so much room for innovation also still in terms of being more efficient, raising quality, and improving the end product as well. So there's also a quite interesting disconnect between, if you look at Europe, as the previous speaker also mentioned, there's a lot of gigafactories in the pipeline. What is lacking is basically the raw material. As I said earlier, we do have the prospects here, but it's a far way until we have that capacity up and running with the related processing capacity as well. So there is a slight disconnect here, but it will be interesting to see how this plays out. So that said, I think I'm soon out of time, so I'm going to wrap it up here. And thank you everyone for listening. And if you like, we have a stand at A6, so you can come and discuss further. Thank you.
Thank you, Stefan. You were already highlighting nicely the real challenge in the materials that we are going to have in the future. We are just starting to ramp up this battery industry, and what's actually a really big problem. It takes less time to get the cell manufacturing plant up than it takes to take the mine up. But the cell manufacturing plant needs the resources from the mine, which goes nicely to our next speaker, Jani Kiuru, who is going to talk, who is a Chief Technology Officer in the Finnish Mineral Group, who is going to talk about discrepancies in safeguarding the future mobility for Europe. Thank you.
Good morning. I'm not saying how nice it's to be in Vaasa. Windy and rainy again, and I had to wake up at 4:30 to get here. But my title is quite noble. I can claim that probably the content is not. Our communications was absent last week, so I took a liberty to put something else here, and I'm now talking about discrepancies, which means that I claim that there is something wrong, and hopefully it's possible to correct those things. And I also realized that previous speakers mostly said already everything. I just put it into a bit different format, and the angle is negative. So let's see if you are the right audience for this. You're free to leave. I just shoot a few examples and then come up with a few solutions, and let's see where we are within 15 minutes. Example 1, who sets the criteria for future mobility? Ideal situation is, of course, that the consumer need would claim what's in there, and when consumers are not correct, then regulation should take an action. And actually the EU Commission document also says this, that the automobile and battery manufacturing companies can directly support higher environmental and social standards compared to activities elsewhere in the world. But how it seems now is that the EV producers define these criteria, and the supply chain then starts to compensate the costs. Not everything is like that, but we'll see that the manufacturers come with the due diligence criteria and various certificates which are then required for the raw material players to comply. Example 2, I promise this is negative. Same rules do not apply for all. I claim that operators outside Europe gain unfair competitive advantage by operating with lower standards. You can see a few examples. Mining in Finland doesn't look like that, and I know it. We own the biggest nickel mine in Europe. There are the local authorities in these foreign countries, third countries. They deal with the environmental and social aspects and regulation, and they are not even close to the same level as in Europe. So in a way, this, and also WTO prevents some actions. So in a way, branding and due diligence should keep European production alive, is my question. Maybe it can. Third example, Europe continues its 1,000-year-long practice to treat the rest of the world as raw material storage. You both already said that. I just put it in the different words. So it started with the expeditions and then continued through colonial ages, and now we are here. Investing heavily in the battery production without much of a concern about local raw materials or supply chain here. And EU again has a nice policies on this. I don't go through these, but in a way there are 3 main things which are not much helping for the local raw material producers. Secure trade agreement with third countries. recycling, reuse, and substitution. I'm sure that no one has anything against that, but it won't help in the near future. And promoting R&D. You already saw the heavy R&D programs, and that's of course good. And then some local targeting, but mostly for Eastern and Central Europe. And then fourth, subsidies are used and allocated unfairly. Everything goes to cell production, almost everything. Just this week, I read from the Commission pages, was it 206 million for SK owns battery plant in Hungary and 96 million for LJ's expansion in Poland. So these public subsidies just keeps coming and they are almost fully for battery production. Okay, then I listed what this could mean. There's not much positivity yet, but I might come to that. So dependency on imported materials gains strength, and Europe is more vulnerable to be influenced. We already see this. High environmental and social standards in Europe are not effective as the operations take place abroad. And also the customers lose the ability to understand anything as the operations are not in their backyard. This tends to, of course, slow down the technology development and R&D as the production is other side of the world. And usually this leads to suffering of the upstream operations as well, and this is normally compensated by distributing more subsidies. Okay, then to the solutions. Mandatory traceability. This is already what Michael showed you. He called it battery passport. But in a way, this is a precondition to everything. So we need to have transparency throughout the supply chain. We need to have important indicators in place: origin, CO2, working condition, child labor. List is endless, and we need to have benchmark values to enable sustainability labels for the products. And it's also difficult to put monetary value on these unless the traceability is verified. And this should be a joint effort. I'm not happy to see that some Central European countries are now taking actions on this, and it again claims that the end users are defining what this actually means. We tried to put this topic into the IPCEI, but Commission threw us out. It was not innovative enough. I'm sure they are right, but it's not a correct place to work in with under the German government. Same rules for all. This is mission impossible, of course, but mine or chemical plant in Africa, Finland, or China should follow the same standards if the products are refined at the same market, meaning in EU. And of course, this to take care of all the supply chain. Otherwise, it's useless. And when this is not possible, then good old tariffs could kick in. Well, this is already set, so subsidies, when do we see billions for mining? And then, of course, other possible solutions. There has been discussion on local content requirements. What if there would be EU rule that 50% of the nickel in MNC batteries needs to be mined from Europe? This would put two prices into this raw material. Or then adaptation of EU regulation outside EU, probably impossible. So what happens when this is in place? We have more expensive EVs. Hopefully environmental and social problems outside EU decreases. We get a nice jump to EU budget as the tariff starts to come in. Balance of EU's mineral industry portfolio improve and security of supply improves. And then I've just read this last sentence out loud. Failure in changing the current path would increase Asian dominance and raw material supply from third countries and jeopardize or even shatter the credibility of electrification, megatrend being a sustainable and responsible alternative to fossils. I also had something about CO2 footprint and something else, but I'm not going into it now as we are running out of time. Thank you.
Thank you, Ani. Well, I don't know what to say to this. Let's say that engineers are needed. We are facing large challenges in all of the levels, in regulatory, in building the capacity, and mining the minerals. It's very clear that we have tough times ahead of us, and at the same time, we have to solve these problems without harming our planet even more. And one of the key focus in that is how to manufacture your sustainable batteries, and probably also do it here in Vaasa, which Marko Kuokkanen will tell us more. Marko is a sales and marketing director in Merinova. Thank you.
Okay, good morning from my side. Nice to be here. Name is Marko Kuokkanen and I come from company Merinova, and I must say that the last days has been extremely busy, so hopefully I do remember to say everything what I was planning to say. But let's take a small, let's say, leap backwards, because I think many of you have heard about, let's say, the battery factories in Vaasa, and actually yesterday evening when I went to home by taxi, the taxi driver started to ask that when do we get this battery factories to Vaasa, and I said to him that unfortunately this is not like a 100-meter race. This is a really like a marathon or let's say that triathlon, so it takes time and you have to practice a lot, and that is what we have been doing for the last years. And let's go to the presentation, and on this slide we have actually gathered the main things, what actually it could mean for us, that what should we do different way than the others are doing, and so we have gathered these slides, and after this Tesla and Northvolt stories, what we, let's say, in the local newspapers quite a lot, and we started actually to study. So before the COVID times, I think I'm let's say that used to be a sales director in a growth company, and in those days we were traveling a lot. But I think now in 2018-19 we were almost traveling more. So we went everywhere to the Asia, so Japan, China, Korea. We were participating on a batteries Europe initiative and trying to understand and trying to learn what to do on such a way that we could get this, let's say, factories to here into Finland and Vaasa, and as we all realize, the competition is extremely hard, and so we wanted to understand, and actually there is one thing what was the first point, thermal heat recovery. In Nordic countries we have a district heating network, so we have a hot water and the pipelines, and we realized that this battery industry is actually creating a lot of waste heat. So if that can be captured, we have something unique. So when we have let's say that the factory what will establish here the, let's say that activities, for example anode manufacturing, they might have a lot of, let's say that waste heat what we can capture, and of course they will get some income for the waste heat. Second thing, what is actually below that, is the closed loop systems. We also realized that when we saw the different kind of factories in Asia, that in Europe, on our environment when we are living here, we have to do things differently, and of course without no emissions. So that was like the second finding what we found out. Then the work was started like 5 years ago, and we have a massive area. And of course, it's a unique opportunity. So we had a target that we don't just want to get the one factory to the Vaasa. We want to get like a full portfolio. So from CAM manufacturing to the anode manufacturing and to the cell manufacturing. So if we could have these players next to each other, we would be really able to create like a new center of excellence on developing batteries. And of course, the whole base for this is that everyone who comes from Vaasa, you know that we have a big industry what really requires batteries. On a moment when we were participating to the Battery Alliance work in Brussels, we realized that also with the Finnish Minerals Group that actually, in principle, we have quite well things in Finland. So we have mines, even it's not, let's say, enough now when we see that how much materials are needed for the battery factories in Europe, but we have mines here and we have refineries close by. So in principle, having the location in Vaasa when we had refineries close by, it would be like an excellent location. And then we also realized that, okay, we are not doing these things alone. On the other side of this small river, we call it sea here in Vaasa. So there's a Sweden and a Northvolt, let's say, that the factory. And then there's a Norway and a Freyr. So we realized that, okay, maybe there could be, let's say, a possibility to do something together. And this Nordic battery belt is from those days. And actually I have to tell you one story. In China, when I explained that about, let's say, the energy hub in Vaasa and what are we doing here and what kind of industry we have, and I could see from the faces that the Vaasa didn't ring any bell on the Chinese customers, and then they asked, what is Vaasa? I said, well, it's a town in Finland. And they were still looking as surprised that, okay, I had to explain what is Finland. So it is a country in Europe, and this is our target. And then we also realized that, okay, that this industry, we of course need a lot of workers, but we also need some experts to help us to ramp up this kind of factory. So then we were thinking that if we do this together, for this possible, let's say, that Asian people, it would be easier to understand Nordics as one unite area. So you have possibilities to change from one place to the other. Then towards the sustainability. This was also seen that Finland actually has been in the last years investing a lot to the wind power. And this came up on discussions with let's say that all these parties who are interested to establish a factory to Vaasa, and they are keen on getting, let's say, that cost-effective wind power. And the good thing is that on a pipeline, there is a lot of new projects. So we're going to reach 5,000 megawatt in quite near future, so 2024. This is the situation what we have at the moment in the Gigavaasa area. You heard about the Johnson Matthey. It was the same what happened to them, but really for us it was a good thing because they started to develop the project here in Vaasa, and actually when somebody is planning to invest this kind of factory, it will give you a lot of speed also, because then we realize that, okay, now we really have to push with all the plannings for the infrastructure in the area. And that really got speed from the Johnson Matthey. And after that, with the Freyr batteries, we also started with the serious discussions. And they also have a memorandum of understanding with the city of Vaasa, and they have reserved a big plot. And actually, currently, it is this environmental process with the authorities here is ongoing. And as we know that at the moment everybody knows batteries, so it is a shame that our processes will take so much time. So it is a really time-consuming, but hopefully, let's say, after the summer, we are on a let's say that the situation that these processes are gone through, and Fryer is closer to be able to make an investment decision. Then we got the third company, Graphintech, and actually they have a reservation for plot 18, and it's for anode manufacturing, and actually it's a joint venture, and the other half comes from India, and actually we have the gentleman here from India. So Vikram, you could wave your hand with your colleague. So they are also proceeding towards, let's say, environmental permitting and to see that what kind of possibilities they have to establish on anode manufacturing in Vaasa. Everybody who comes from Vaasa, they know this Strömsö model, and everything goes like in a Strömsö. And of course, when we are from this area, we have also very ambitious targets. And for the whole area, we define that to be able to make all these companies which are coming to the area, we need a service provider what could bring different kind of services like industrial gases and industrial waters, all to the players with a very cost-effective pricing. So that was, let's say, the starting point. And this was not our invention, and we were proudly, let's say, not copy and pasting, but the company which is, let's say, planning to do this has done it in Tornio Steelworks and in Raahe Steelworks. So this is actually nothing new. And but this is really required, and it can, let's say, that make easier for coming companies that they don't have to invest everything by themselves. So we have like a central system for the companies. This year actually is going to happen a lot. City of Vaasa is investing heavily in the area. So the main roads inside the area are going to be constructed this year, including all this, let's say, required infrastructure under the roads. So you can see it from this picture. So this is the airport, this road and this road are already ready and existing. So these main roads inside the area are going to be constructed now on this summer. And this plot belongs to the Fryer, and this plot is Graphintech's reservation. I'm going to jump directly here. So this is from Fryer's environmental program. So this is the illustration that how could it look like if all the 4 phases what they have been planning to the area, that how big, let's say, that the area it will take. So you can see that here is the length of the airport. So you understand the sizes of these battery factories, what it could look like. This was actually all what I was going to say, and hopefully, let's say that I raised up some questions to your mind. So let's say that during our discussion on fire chat, you can also perhaps ask some questions from us. So thank you from my side.
Thank you. Thank you very much, Marko. And now just give us a minute to get chairs on here, and I would like to welcome all our speakers back on this panel discussion. And I hope that we will get questions from the audience. So prepare your hardest questions to this fine group of gentlemen, because we really have like really high experts here today with us. Thank you. Yes, free seating. We talk a lot about the raw materials, and I could start with a question, maybe to all, mostly to Jani. when will we have a situation that we can proudly say that Finland could be producing all the nickel, cobalt, and lithium for the batteries in Nordics? Is that a utopia, or could that happen?
Won't happen. But yeah, if we look the mineral reserves which have been recognized in Finland and expect that all these mining projects turn into actual mines, it's a significant amount of nickel production, but it's not enough for all the Nordics, of course, depending on what scale of the project there will be. But in a way, Terrafame is now the biggest mine in Europe, and it produces, it has globally the biggest battery chemical plant, which is in the ramp up, and it barely can feed one huge gigafactory, and that's about the size of the mine that can be in Finland, and there are just only few others available. Boliden have, of course, project in Kevitsa. Anglo has a project in Sakatti, and then some more smaller ones, but in a way, not enough. So we will be depending on recycling and imported materials if the battery production expands here. Of course, depending on the technology. It might not be nickel-based chemistries.
Yeah, that's true. That's true. Do we have questions from the audience? Yeah.
My name is Raimo Opera from Turku Science, Turku region. Actually, I'm asking mostly Mihail. You mentioned the transport, but there's also one section which is missing, which is actually the utility and heavy-duty machines, for example, in the mining industry, because that will also cause a reduction of CO2, because you don't need to have that heavy ventilation in mines and stuff like that. And forestry is also, of course, also important in Finland. How is that taken care of in the programs?
So the first thing is to say that, remember my first slide said whatever we can electrify will be electrified, and I strongly believe in this. And I do include, when we talk about transportation, I do include also off-road and heavy machinery. It's certainly part of the game. Now, for time reasons, I didn't go into all the details, but even on my little scheme, you see a forklift truck, I think something like this. So it's part of it. Now, it is difficult to address this segment specifically in the overall area, because I mean electric vehicles or transportation are so dominant by volume. Simply, if you look at the amount of batteries we would need for this segment, it's relatively small. But I don't say we don't care. It's the contrary. I think we have an excellent chance of having huge volumes and capacity to develop electric vehicles. Many things we do for electric vehicles and buses will benefit to the rest of the segments. Now, the battery for a big truck or for a mining truck will not be exactly the same than you will find in your electric car. Nevertheless, what we are talking about in battery technology is how do we reduce by 50% the weight of a battery? How do we increase the lifetime, and how do we increase or decrease the cost of this battery? If we achieve this for an electric vehicle with a high economies of scale and volume effect, it will automatically benefit to the other markets. What we do need, and again, this is what I briefly said about the relationships with other sectors, is to use these results and transfer them down into, as I said, the aviation sector, the railway sector, but also including the heavy machinery sector, for sure. And I'm very proud to say that one of my first trips, but many, many years ago to Finland, was, I just mentioned this, to work with Kiruna trucks, where my company I'm working for, I did not mention this, Saft is a battery manufacturer, where we delivered a battery to Kiruna truck, which was then going to Australia into a mine. And it's exactly what you said, because down this mine there was no diesel engine allowed, so it was running on overhead lines, but needed a battery for some manipulation works. So I really agree what you're saying, and it corresponds to my personal experience as well.
I think it also interconnects to the battery passport that was mentioned earlier, that you need to have the CO2 footprint, and also the mining companies needs to go to net zero eventually. And in order to get the right CO2 footprint of the individual cells, you also need to have a raw material that is CO2 neutral as close by, and this would trickle down to the manufacturers of these heavy-duty vehicles. I'm convinced about that.
You can continue.
Thank you. Maybe for a small addition is that the logistics and how the machines work in mines are completely different than it's in transport. You don't have a time for charge your batteries. You have to replace them or change. So you have to have also some different kind of R&D going on, and the different solutions to work with that. That's just a comment.
So happy to work and to create links if you believe that these links are not established. Again, from a personal experience, we are working today with the aviation industry, because a battery in an airplane, of course, is not the same than in a car. We are working with the rail industry because they think of, well, how do they get rid of their diesel engines? And you imagine a battery on a train, again, is not the same than on an electric vehicle. But still, they need to have the weight and to have the cost, and to have extended cycle life. And by the way, much longer cycle life than in an electric vehicle. I don't even talk about the stationary segment, but if there is a work stream, an association, a body that puts together the needs of this heavy machinery or mining truck industry and wants to talk to the battery industry or to the battery research and innovation platform, please come to see me.
Yeah, I have a question also. You have been talking a lot about batteries, but what about supercapacitors? I mean, for stationary systems, they could be a very interesting alternative, getting rid of a lot of minerals, especially those nasty ones. Mm-hmm. Is there any, how much focus is being put on supercapacitors and their development?
To be honest, for what concerns the scope of what Batteries Europe is working on, it is really focusing on batteries. And here again, I think it is due to just the amount, the volume effect, and the perimeter of the batteries. Even on the stationary side, what we will need I mean, what we need already today, and even more so if we want to integrate increasingly renewables, is battery energy storage for in order to ensure first of all the stability, and secondly the flexibility of the grid, which means we need storage for intraday, several hours, around 4 to 8 hours, and this will require huge amounts of gigawatt hour of let's say energy storage. Supercapacitors have a very narrow part of this spectrum. So I don't say that we don't need supercapacitors and that they don't have certain advantages, but for what concerns Batteries Europe, today we focus on the battery technology side.
Yeah, but for instance, the IPCEI, it covers also supercapacitors, at least I think the German one. We were preparing it, and there are companies working on that. But it's not part of Batteries Europe.
I could actually comment regarding Raimo's question regarding this mining machine, let's say, company. So few of the, say that this machine companies, they have been using the batteries on their big machines. So this is like the normal, let's say, business already for many years. And have to mention that one of the first ones who were, let's say, that Northvolt's customers were the Swedish, let's say, that the mining machine company. So this is nowadays, I would say, like a normal business. So.
Andrei Shugaev, Geyser Batteries. The discussion seems to be totally focused on the mobility market and on lithium-ion batteries, which makes sense because basically those are linked together. But lithium-ion batteries are really not sustainable for stationary storage. No recycling, questionable supply chain, extremely flammable, toxic. Are there any efforts among your companies in developing other more sustainable technologies for stationary market, like redox flow or others?
Who wants to?
So I probably have to take this again. It is absolutely true, as I tried to show, that the battery industry needs is driven by the transportation, and the technology for this decade is and will be lithium-ion batteries. And in order to do this, we need not only to scale up, but, and I really stress this, we need to work on their sustainability aspects, on safety aspects as well, and you know, we are going towards solid-state batteries that have different characteristics, also with regards to their, say, safety characteristics. And we need to work on the recycling side. Obviously, recycling at scale has a 10 years time lag over the manufacturing, because simply these batteries last 10 years in the field, and if you want to invest into a recycling plant, you want to make sure that there is enough volume that needs to come up. So the first thing, I'm sorry to say, but we cannot state that the lithium batteries as such are not recyclable and dangerous and flammable. I mean, they have certain characteristics we need to take care of, we need to improve, and this is part of the research and innovation activity. Now, when it comes to other technologies, I clearly acknowledge that lithium-ion is not the end of the story. It is really the technology we need and we will have for this decade, and we need to work, and we do work in parallel on other technologies. And we by the way, will have in the next work program a program on redox flow. So redox flow are a part of the contender technologies, and we are looking beyond, of course, also the future generations of lithium-based or other materials-based battery technologies that we will develop. We need to, I mean, we have already started to work on this. It's not that nothing is done on this, but we need to invest on these technologies now in order to have them readily available beyond 2030. So it is not one thing only and nothing for the rest. It is to have a proportionate effort on what we do now and how we look into the future. Now, this again saying, and I maybe finish with this, if we look at it from a European perspective, and if we want to have again a competitive, sustainable industry for this decade here, we need to match our goal in 2025. If we miss our goal in 2025, if in 2025 or in 2028 we still say that we didn't make it in Europe and we are depending on the raw materials, it's a real issue, but also on the battery on Asia, then everything thinking beyond 2030 and 2040 is nice talks. So yes, we have an urgency to to achieve our targets by 2025. I do say this because it seems like everything is going into only one technology and to only one segment. But it is also the industrial reality to achieve these short-term targets. We must not miss it.
Thank you. Anyone else wants to comment?
Yeah, maybe from From my company's point of view, of course, our turnover is heavily relies on nickel and cobalt pricing, and that's our main focus. But a bit more than a year ago, we acquired Sokli project, which is iron and phosphate project, and after that we have activated a technical and economical assessment to study if phosphate and iron from Sokli would be competitive for LFP type batteries, and that's ongoing work. But of course, it's still an early stage project, so not expecting this material to start flow anytime soon. But there's some activities on other technologies as well.
I can only echo the words of the previous speakers, but when we look at the applications where we use batteries ourselves, for example, within railroad applications, traction control, we do use different chemistries that are more cycled to these heavy-duty application and loading. And also, of course, within energy storage, there will be a variety of chemistries also available. So, but it's quite easy that focus is on lithium-ion batteries, since that is where the growth is going right now. That's where the momentum is obviously much stronger than the other chemistries.
Okay, question to Janni, Finnish Minerals Group. You mentioned that the inequality between, let's say, the European standard of mining and then the rest of the world mining. Of course, it's a huge difference. And you mentioned that one way of maybe trying to solve that is tariffs. Could you maybe elaborate that a little bit more? Is there are there thoughts of that in maybe on the EU side, on the legislative side, or is that like a dead end that is an idea but it could never be realized?
Okay, probably it's a dead end. But I don't see that the EU would come up with such tariffs, but in a way, we have seen efforts. For instance, with LME, they announced a few years ago that they will start trading cobalt with two different prices, sort of a sustainable and responsible cobalt and the other stuff. It failed. They moved it forward, but I think that the initiative is still there, and kind of a reason why it failed is probably because there is no reliable way to prove anything. So all these battery passports and traceability initiatives and all the ID required to verify the origin and the conditions there and put up the auditing systems takes time, and hopefully this will succeed at some day. But of course, when this succeeds, it also enables putting tariffs, because we know then what the conditions are. But I wouldn't be too hopeful that the EU would put those tariffs on, because of course there are a lot of battery manufacturers who need raw materials, and it would be quite catastrophic to increase heavily prices, although they are now increasing anyway, but we'll see how this goes.
I could continue from this battery passport idea. If someone is not familiar in the audience about battery passport idea, well, it was nicely presented here, but batteries have been basically chosen as to be this first prototype of this passport idea. There will be other passports also in the future, and it's basically now in the testing how we can apply this battery passport into the battery industry. And I would like to hear from our expert. We have a cell and the equipment and more on the regulation side and the mining. How will the battery passport affect on what you are trying to accomplish? So Marko, if you could start from there.
Well, if I start, we all have seen our, let's say, if you go to the kitchen and you look the oven and all these machines what you have in every house, so they have some kind of sticker there showing that is it A class or what kind of class it is. So on overall, I think it would be very good, but of course, it's always a challenge, like you previous speakers mentioned, that it's not so easy task. It will take some time to implement this battery passport, but I really think that it would be very good for, let's say that when we think about the sustainability things. So I'm really, let's say that supporting the idea.
I'm going to take a slightly more optimistic approach. I believe that looking at, for example, you are able, the technologies there, how you would be able to track this technically from the mining, basically. You would be able to track it throughout the logistics chain. You would also, looking at the production plants that you have for active material today, in the production sites, the systems that are in place already, technologically speaking, when you look at the mass balance on what you consume in terms of energy and you have a good understanding on the raw material you are refining, and you just match that what is coming in equals the outgoing product, then you have the data there. So I think you could actually today already have solutions in place for this traceability throughout the value chain, technologically speaking. So I'm a bit more optimistic there, and I also think it will be also driven by the market. I think consumers will have a big interest when you buy a car. It's a branding value, for example. If you buy a premium car, I would expect that the consumers also would like to see that this does not include any conflict minerals or other things. But I'm taking the optimistic stand in this. So.
Well, I mean, I'm sure we are going into the right direction. I mean, the difficulties are there, but it doesn't mean that we say, oh, so it's nothing to do, or we just let it go. I mean, you understand that the problems are complex. I mean, they are political, geopolitical, and really to make sure that the battery you drive in your car here in Finland, to have this traceability on where the cobalt comes from, not only where but under which condition it has been sourced, it's a real challenge. But it doesn't mean that we don't want to address it. And when I'm talking yesterday to Calibre, for example, they tell us that they have in place this kind of systems, and they know precisely whom they are working with. Of course, the cobalt comes from Congo, but it does not necessarily mean that there is child labor and that they are under non-responsible conditions. So at least that's what they're telling us. Now, I cannot go there and check it by myself, but this is what we put into place. And maybe to add to this European perspective, maybe I'm wrong, but I think probably batteries are one of the first industries that will see very stringent regulation with regards to sustainability. The European Battery Directive, which is going to be implemented very soon, will first of all define a carbon footprint for batteries. So we need to define what it is, and we need to declare it. And on the longer term, we will have limits, so a maximum carbon footprint that will be allowed. We will have targets we will measure the amount of recyclable materials that go into this battery. And again, the first thing is to say we define things. Then we monitor things, so we know how much recyclable material is in there, in order to, on the long term, establish targets or thresholds. So in 2030 or 2035, there will be obligations to have certain amounts and quite significant amounts of recycled materials, and so on and so on. I just took two measures out of this. I don't know if there are other industries today that are going into these directions and that have this kind of strong, let's say, regulatory obligations in terms of traceability, in terms of sustainability as such. And we do not take this as a burden or a negative thing. Of course, we try to implement it with the European Commission in a feasible way, because you do not need to overshoot. I mean, if you talk to a politician, he has very bright ideas, and then we say, yeah, but we need to be able to do it. I mean, and it needs to make sense what we do, and it needs to be understandable, and it needs to be implementable. So these are the kind of discussions we have. And again, you see the difficulty. It's not just like saying, well, define your carbon footprint and put it on your label like you have on your washing machine. It's a little bit more complex, but we're going along this way, and maybe even as a precursor for many other industries in Europe.
And if you still want to click.
No, yeah, maybe we still didn't discuss the IT part of this. So it's one of the bottlenecks is that there are now a few IT systems that are designed to provide traceability. They are based on blockchains and highly complex. I don't understand any of it, but they are not interoperable. And this is the problem when you are, for instance, advanced material producer and you are not probably single sourcing anything. You are buying it from different sulfate producers and then they are operating in different systems. So that's one issue to be solved. And I'm probably not a huge, I'm sure that the IT guys can work on that, but still another issue is that we have now ongoing traceability readiness assessment at Terrafame, where we are trying to trace the CO2 footprint with Circular, which is one of the IT suppliers. And it's not a problem to actually produce the CO2 footprint and attack it with the sulfate back. It's quite easy and it works. But if you want to go live, meaning that the actual measure the online CO2 footprint from the production, which will be the case, it will then require heavy updates on the automation systems. Good news for you probably, but someone needs to pay that if EU puts that on the regulation. And on the other hand, we still do want to trace the CO2 footprint. It will be beneficial for us when it starts to determine the price of the product.
Thank you.
I'm sure we can find cost-effective solutions. That's not a problem. So.
Thank you. Maybe, hopefully, short question.
All right, short question. So Hans-Alexander Öst from Vaasan Sähkö. A question to Michael. I saw you had solid-state batteries mentioned in your presentation, and today we can see that semi-solid state is starting to make a breakthrough also on the lithium-ion market. What do we do on EU level, and how do we ensure that we are in EU ready when solid state is also ready for the market?
Well, for what concerns the research and innovation programs, what we call generation 4 for A, for B, and this is the way towards solid state, have a very prominent part of, or substantial part of the fundings, or in fact they have an important place in the work programs 21 and 22, and by the way, both on the material research and on the manufacturability. And this was new. So we recognize that. If I say we recognize, the industry sits around the table and says, what do we need to invest on, what is important on the short term, and this is has a very prominent place in this area. Now you can always say it's probably not enough, because if we finance 4 programs, there are maybe 8 or 10 candidates who would like to get on this. But very concretely, in the work program 2021, there are 4 programs on generation 4A, 4B. On the material side, and I think 3 or 4 others on the manufacturing side. So this is, I mean, the general statement I can do. No, I don't know precisely who is doing what in this, but I can tell you that I mean the industries I'm working for are progressing well on this area.
Thank you. Let's give a big round of applause for our great panelists. We will close our session here, but let's be back in soonish, so with the next session. Thank you.
Thank you.
Thank you.